Hi, I'm Chris, and in this video we're going to take a look at Hardy-Weinberg equations, and this is part 2. So if you haven't seen part 1, or if you're just getting started with Hardy-Weinberg and you need a little bit of an introduction to some of the terminology, please feel free to watch part 1. But if you would like to go ahead and try out this question, we're going to assume that we already know our two Hardy-Weinberg equations that we need for this, which are p plus q equals 1 and p squared plus 2pq, plus q squared equals 1. So these are our two Hardy-Weinberg equations that we would need to use to answer a question like this. And the question from part 1 asked us if 16% of a population physically displayed a recessive trait, but in this case we've just changed that percentage to 4% so that we can run through a new calculation and make sure that we really understand how it works. So here we go. One thing we mentioned in our first video, which I'll reiterate here just to make sure we understand, p squared represents your homozygous dominant portion of your population. Q squared represents homozygous recessive. And what we're being asked for in this question, the heterozygous portion of the population, is represented here by 2pq. So this is ultimately what we need to solve for, but first we need to use the fact that they give us 4% of the population that physically displays the recessive trait. And that is going to refer to your homozygous recessive portion of the population, your q squared. Because in order to actually physically display or have a phenotype that is recessive, it means you need to have both copies of that recessive allele. So in this case, we would have q squared, which represents the portion of the population that's homozygous recessive. That's equal to 4%, and when we do our calculations, and mathematically, generally speaking, anytime you work with percentages, while you're doing the calculations, you want to treat your percents as decimals. So here, 4% will be written as 0.04. And when we take the square root of each side, we get q equals 0.2. And if you want to double check, you just multiply 0.2 times 0.2. Comes out to give you 0.04. And then we take this value of q, and this is where we use this first equation. We're going to apply q to this equation, and when we plug in 0.2 for q, we can solve for p. P plus 0.2 equals 1, p equals 0.8. And for the heterozygous portion of our population, which we're looking for, 2pq, we simply plug in the value of p and the value of q. This is 2 times 0.8 times 0.2, which gives us 0.32, and when we convert to a percentage, that is 32%. So for this question, 32% of this population, where 4% of the people express the recessive trait, 32% would be heterozygous for that trait. Heterozygous meaning they have one dominant and one recessive allele. Please feel free to visit our website at sandersontestprep.com, or you can watch further videos on the biology channel of STP TV. Thanks for watching.